4:30, you almost made it. So it's funny that this session is the last one. I'm kind of hoping it's one of the first ones, but so this session is basically a session I would like to give myself like 2 or 3 years ago. Because when we all tried to figure out what this all is, oh well, this was quite hard. So what I want to do is, let's make this a safe space. No question in the next hour is too dumb, too stupid, or whatever. Ask anything. Like, I've spent a lot of time in this world, and I banged my head against trying to understand, because I think engineers sometimes have really a problem of creating new terms for existing things. So I'm trying to make it as simple as possible. I'm trying to make it as easy as possible. But if something does not make sense, before we go to the next slide, please raise your hand. Let's go through this together. I know this is all new. This is all scary also. But I'm here to brain dump everything I know, and I might not everything know. There's tools called LLMs we can use to answer questions, so we'll see. But basically, what I want to go through, about me. My name is Michael, or a lot of people know me about Schnitzel. I'm the founder and general manager of Amazing.io. I live in Virginia. I used to do a lot of tech stuff. Now I'm happy if I write 1 line of code a week, because I manage a lot. But all right, let's go. All right, the agenda, we're going to talk about LLMs and prompts. Then we're going to look into VectorDBs and RAG. We're going to learn what fine-tuning is. We're going to talk about this new fancy term MCP. And then we're going to talk about agents and agentic frameworks. And the last, we're going to talk about hallucinations. All right, so what is an LLM? What you'll see in my slides is always this arrow. That's basically the super simple thing. If you learn that, you already learned a lot. So an LLM is basically a very good autocomplete. That's what it is. So what they do, an LLM, it basically just reads a lot of text, and it learns that, for example, when a word starts with my name, that a high chance is that the next word is. Like, my name is Michael. So it just reads a lot of text. We're talking about the whole internet. We're talking about every encyclopedia in the world. We're talking about every word that you can find. And based on just learning or reading all this text and looking at these patterns in text, an LLM starts to learn. And if you do this enough, with enough compute power, what we've learned is that an LLM is actually starting to be able to predict the next word in such good ways that it can start to answer questions, but not only that, but it can also create new things that didn't exist yet. That's how deep I'm going to go into. So an LLM is basically a very, very good autocomplete, that just is very good in predicting the next word based on all the words before. And LLMs have 2 main stages. There's a training stage, and then there's the so-called inference stage, or you can say the inference stage is that you run the model. So that's the important part. All right, let's look at that. So training versus inference. It's basically, you go to school first, the LLM goes to school, and then it actually does the job. So that's the 2 differences. So that's the easiest way. You teach a kid about something in school, and then later on they expect to learn it or to do whatever they learned on the job. So training is large. So we're talking about the whole internet. We're talking about everything you can find on the internet. So we talk about Reddit, we're talking about Wikipedia, we're talking about everything. And the thing is that you need GPUs for this, because GPUs are very good in running a lot of things in parallel. And how LLMs work is that you have a lot of parallel consumption. It doesn't matter why, but that's what you can know. And then there's some evaluation happening, so you verify that the LLM is actually doing what you expect, and then you release it. Now you can do, that's one of the cool things, with LLMs, you can always train them more. We're going to go into this with fine-tuning. But you can always do more. And then the inference is what we talked about. That's then when you actually ask an LLM something and it runs. That's why I'm calling it the running step. That's the inference step. Again, our machine learning friends, engineers, they like fancy terms, so they call it inference instead of running, but that's the running part. Now, what is important is that training is what happens rarely and is extremely expensive. So we talk about training, if like OpenAI, Anthropic, or xAI, or whatever, they do training, we're talking millions of dollars. Because you need massive amount of GPU clusters that use massive amounts of power. So that's the really expensive part. Training these models costs millions of dollars. However, the inference is then per request, and it only runs while the request is answering. So that's why we can run LLMs on our computers. We already have LLMs that can run on our phones. So the expensive part is the training. The running or inference stage is the simpler one. Now, you still need powerful computers to run them, but it's compared to the training, we're talking million-fold difference in terms of infrastructure difference. And I think that's sometimes confusing because people ask me, like, how can Amazy, a small 50-people company, run these models? Don't they cost millions of dollars? Yes, they cost millions of dollars to train, but to run them, it does not. So an LLM that runs for a couple of seconds costs you a couple of cents or sub-cents. Because you only need the GPU or whatever is only used for that short amount of time. Makes all sense? Cool. All right, you've probably heard prompts. These are just the instructions, or that's the task that we tell the LLM to do. So if you talk about prompting, it's basically we tell the model what we expect it to do. So if you go to ChatGPT and you write something in it, that text that you write in there is called the prompt. That's what you're doing. And it's your way to steer the model towards a goal. Right? If I go to an LLM and saying, like, I need you to write a thank you letter to my sister for the birthday present that she gave me, you're prompting the model for a specific goal, and you're trying to tell the model what that goal is. Important is that clear scoped instructions. If you're very clear with the model what you expect, the better the output is. And what is really good is, obviously, we realize that the quality of the AI has actually a lot to do with the prompting. Yes, it has to do also with the training before, but it actually has much more to do with the prompting. And one of the really good things is that you give it an instruction, what do you expect, but also give it examples. This is called few-shotting. I have no idea why people come up with these names, but that's what it's called. So if you give a model not only what you expected, but if you also have an example of how you expect it. So for example, if you wrote already, in my case before, if I already have a thank you message that I wrote maybe last year by hand, because the LLM didn't exist yet, if I give that to the LLM and ask it, use the same style or create a message as I did before, it's going to way more likely create something that I like, because I literally wrote it last year, with a new one. So if you have an example, give the model an example. It's going to create much better responses. So for example, or no, then the next thing is give it constraints and style. So in my example is tell it how long it should be, and what style should I use, what do you expect, all these things. So not just like expect it to do what you think or what you hope to do, tell it if you have a specific expectation. I think that's kind of something new that we're not used to. But that is really helpful if we tell a model or in the prompt, and then at the last, also tell it in what form do you expect it. So do you expect a markdown? Do you expect an HTML? Do you expect JSON? Do you expect regular text? And if you expect a JSON, give it an example of a JSON. So that's extremely helpful because the model, again, it has no idea what you want from it. If you don't tell it, it will assume, and it might do it wrong. Now, as I mentioned before, there's prompting, we realize, is a very important thing. So companies like Anthropic behind Claude or Google and also others, they now have whole prompt libraries that you can learn how good prompts are written. They explain you why these prompts. And not only that, Anthropic actually created a prompt validator, which you can give the prompt in it, and it will tell you possible issues that could be seen and stuff like that. So a lot of the focus today around AI happens around prompting. And you probably also heard the word prompt engineer, and that's literally a job that now starts to evolve, because how do I tell these models how to do it in specific cases can be a skill by itself. I think all of us need to learn this, right? So like we have race car drivers that are really good in driving very fast cars, but all of us can drive. We don't have to all be race car drivers. The same in engineering. Like, I think we all should learn. So if you have some time, if you look for prompt galleries and prompt engineering, that's a really good skill to learn, because that's something that did not exist 2 years ago, 3 years ago. This does not exist at all. This skill of prompt engineering and what a prompt actually is. Now, to make it a little bit more complex, there is actually multiple types of prompts. So there's a system prompt and there's the user prompt. You can think about that the system prompt is the fixed thing that you define once, and then in the user prompt is what everything changes of the specific request. So let's say the system prompt would be in a Drupal site. So if I'm a Drupal site that can give, let's use the example of before, I'm a Drupal site that can give legal advice for visa holders in the US. The system prompt will probably say, hey, you're a helpful assistant that gives feedback of visas and things like that. That's the information you have access to, blah, blah, blah. You always should respond in that X, Y, and Z and things like that. So that prompt is probably built once by a self-builder or a prompt engineer into Drupal. So if you go in Drupal, you will see sometimes the system prompt. That's where the standard definitions is. And then when the user comes, let's say I'm a visa holder in the US, and I go and say, like, for how long can an L1 visa be specifically? That is then the user prompt. And what Drupal does, it takes the system prompt and the user prompt, that's my question, together is sent to the LLM. So the LLM receives one thing with the system prompt first and the user prompt at the end. And then the LLM knows what to respond. And the system prompt is basically where you can also put in refusal things. So you can say, you don't talk about visa rules of other countries. Because right, the LLM probably has heard about visa rules of other countries. But if we say our website is only about US visa, then you can tell it in the system prompt, even though the user asks about other countries, you tell it in there, do not talk about X, Y, or about other visa rules, or something else you may want to point in. So that's your way, when you build interfaces for other people to use, to steer them again, to create guardrails around them. Or also output format hints. So you can say, unless the customer asks for a long response, right? Unless the user asks for a long response, just write 2 or 3 sentences. Very concise. So that's also the possibility. And you can use words like unless. So you can say, unless the user asks for it, don't do something. Again, we need to tell the LLM what we expect from it, and that can also happen in the system prompt, which we define once, which is then combined with the user prompt. Does that make sense? It's really important, because there's unfortunately more than just one prompt. Okay. All right. So let's talk about vector databases. And basically, if you want to learn one thing, it's the new Solr. That's it. So we used to use all the Solrs, now we use vector databases. So how does it work? Basically, a Solr is keyword search based, or at least the current version of Solr is keyword search based. So it matches words. So if I have all my Drupal text, and I go in and I search for, let's say I have a recipe database, and I search for the word Italian, and the word Italian, the actual word Italian, appears in that content, I will respond, the Solr can respond with it. Vectors is different. So vectors actually understand the meaning of text. So if I have a recipe that says, this is an Italian recipe, because the vector database also understands that the Italian in Italy, for example, is the same or is similar. Right? It's much similar. Italian and Italy is much similar than Russian and Italy. So, like in a vector database, you need to imagine this is like a multi-dimensional vector database. These words are closer together in a multi-dimensional space. It's hard for us to imagine because we know exactly 3 dimensions, but this is like 100,000 dimensions. But they're basically closer to each other. So, if I ask for a recipe from Italy, a vector database knows that Italy is very close to Italian, and even though there's no exact matches for Italy in the content, it can respond with Italian recipes, and it will not respond with Russian or recipes from Russia content. So the problem is, or vectors are actually mathematical, it's numbers. So in order to do this multidimensional thing, you maybe learned in school, vectors are just numbers, and so we need to convert them. We need to convert them from text into numbers. And that happens with embedding. So embedding is basically the thing from converting from text into numbers. That's all it does. And what is really great vector databases, like I've said, they're really good in finding relevant snippets. Specifically, if you don't find a specific answer for the question, it's really good in knowing, oh, these things probably have to do with that. So, and we can use that, vector databases, we can use with RAG. So RAG is called Retrieval Augmented Generation. The simple one is just called AI search. Like that's what RAG is, AI searching.
Say that again?
RAG is AI search.
Yeah, sure.
So think about, if you hear RAG, think about AI searching. And you're 99% correct. So the idea is, if I want to have an AI or an LLM give me a question, back to my visa question from before. Let's say there are, I don't know, probably 50 different visas in the US that exist. Now instead in my system prompt, to tell the LLM about every single visa that exists, which is going to be a massive prompt, like you're going to write a massive prompt that explains the LLM about every visa, wouldn't it be great if I actually can store all the visa types and everything that exists in a database? And when the question comes, like I have a question about L1 visas, how long can I extend them? That I could only give the LLM, I could only give information about the L1, right? Because nobody asked about H1B, nobody asked about the O1s, whatever. That's what RAG does. So instead of taking everything that your Drupal site knows and giving it all to the LLM, then hopefully giving the right answer, what you do is you help the model with just giving it specific information. And then you ask the LLM, and now give me the answer. And the benefits from that is, it's fresher, meaning older content is no longer there. It's way more accurate, because the LLM is not confused that it reads a lot of other visa types. And that means also it has reduced hallucinations.
So where does that happen? Where do you configure that?
Yes, we'll get there. All right, so the first thing we have to do, we have to actually take our documents. So that would be in Drupal. Let's say you have nodes that describes every visa type. So for every visa type, you have a Drupal node. And what you do is you run them through a so-called embedding model, where it takes the text of the node and it converts it into numbers. So that's an API endpoint that you go through an embedding model and saying, here's a Drupal node, and you do that. Now in Drupal, this happens in Search API. So Search API is able to access all the nodes, right? And it usually sends it to Solr. Now in this case, it actually sends it first to embedding model. So you send the text of the visa to an embedding model, and the response is numbers. They're just numbers that are coming back. And then you take these numbers, so that happens here, and then you take these numbers in this step 0 and you send it to the vector database. You say, vector database here, store that data, please. That is called embedding. So what you did, you just embedded the content into a vector database. This needs to happen once. And it's done by Drupal by Search API. So if you look, there's Search API VectorDB plugins or modules that you can use. You need an embedding model. Most AI providers offer embedding models beside of LLM models. They're super simple, they're extremely cheap, they're very fast, because all they do is just convert text into numbers. That is done once. Now, if your document changes because you go in and the node is changed by an editor, you need to do this again. But Search API is great because it actually knows what went changed in Drupal, and so it only will re-embed the node that just changed. It will not do the whole thing. But Search API handles all of this in Drupal. Extremely great, very cool that we have this. Okay, so the next thing is when I actually have a question. So let's say I'm asking, how long can L1 visas be renewed? So I sent this to my AI app. In this case, this is a Drupal app. So I have a chatbot in Drupal and I type in, how long can L1 visas be renewed? And then the Drupal says, oh, I will first go to the vector database to get information about visas. And because so I sent the request to this question. It's then sent to the vector database as well. And then the vector database, because it knows L1 visa, so it will match nodes for L1 will be more matched than nodes for H1B or O1. Because in this multidimensional thing, the L1 node lives closer to my question. So my question will also be assumed in this space. And you can just think about like they're like bubbles that are really close to each other. So I take a net and I take all the bubbles that are close. That could also be that maybe I get an L2 visa. I don't know if that exists. Let's assume it does exist. There's an L2 and an L3 visa. That maybe also comes back. That's okay. What I want is instead of having every visa, I just want something that is close, right? So the vector database will not give me the answer. It will not give me the answer, but it will give me related content to that question. So that comes back. Let's say Drupal or the vector database comes back with 3 nodes, the L1, L2, and L3 visa information. Now the information in it has the information like 7 years, that's the correct answer, but it also has a lot of other answers, so it's like a full Drupal node with a lot of text. And then Drupal takes that, and now the system prompt that we talked about, the user prompt, which is what my question, and the node, so the actual content from the vector database, so the whole node, so if you look at it, just a node, just like all the content, is sent to the large language model. And the system prompt says, hey, large language model, you're a helpful assistant with visas, blah, 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 blah. This is the question of the user, and here is relevant information for that question, and only use answers that you find in that content. Forget everything else you know about visas. Because, who knows, maybe when the model was trained, which was maybe last year, maybe L1 visas were able to be extended by 12 years. So the model actually learned, oh, L1 is like 12 years. But you tell it, use only that information, because that's the most updated information. And if you tell it correctly, what it will do, it will look all of this. It will look at all the text. It will see L2, I don't need that, but I got it, okay. So it will do all its LLM fanciness, and it will come back with the answer 7 years, and it will send this back to my person. Nope. So that's called RAG. Any questions? Until I understood that, by the way, it took me like 6 months. So this is extremely cool. Most of the fancy stuff that we're seeing right now with Drupal and AI search and all that stuff, like that you can go to a support bot and the support bot can give you answers and all that stuff, it's all RAG. You think all AI search. That's all it is. That happens again and again and again and again and again. And that's one of the major things that are now possible. Because before, all we could do is give the vector database response to the user. So we could give it 3 nodes, and it's like, yeah, maybe this first node has to do with L1, and then the user had to go by itself and go. But now we can give it to a large language model saying like, hey, here are possible answers. Can you help the user? There was a question.
Yeah, what's stopping it from receiving incorrect data versus correct data?
okay, so there's two ways how the model could get wrong information back. One, it actually gets wrong information from the vector database. So let's say if the vector database obviously has 12 years in it, which is wrong, the LLM cannot figure it out. So the LLM just really depends that the vector database is up to date. So this process here, which is the 0, 0 here, this constantly needs to happen, and it needs to be updated.
That's what I meant. Like I mean the information coming from the document section. How do we verify whether that's correct and correct?
So that's what Drupal Search API does. That's its job, is to constantly up-to-date the vector database with the newest node of Drupal. So it like for example, if you go into Drupal and you update a node, that it then realizes something has changed in this node, needs to throw it to the embedding model, and needs to throw it back into the vector database. So that's just Search API. Now, it has done forever. So this was a job forever. That's like with Solr, it's the same problem, right? So like, you also could get wrong data back from a Solr database. So that part that's the really cool stuff, by the way. Most other open source CMSs don't have that part at all. So the fact that we as Drupal already has this is phenomenal. Like that's really cool because it's correct. So that's one way that it could just receive wrong data. And the other thing is the large language model. Let's say for whatever reason, the retrieval here actually doesn't respond anything about an L1 visa. It only has information about the O1 and the H1B in it. And the LLM is trained to be extremely helpful. And in the world of the LLM, helpful is giving an answer, is the helpfulness. So if your system prompt does not say, if you don't find any information in the part that I sent you, please say, I do not know. And don't make up your own thing. Because unfortunately, the LLM has been maybe trained about L1 information in the past when it was trained about everything, right? So it could be there. Or for whatever else reason, it thinks that today I'm extremely helpful. I'm going to write you something that you want to know. And that's the danger, that it then will bring back something that it actually doesn't know, because the data that in here was given is not complete or not fully correct. And that's what, in my experience right now, is the biggest issue, that the data that is asked about, or the vector database, while it's correct, it's maybe not complete. And then the LLM thinks, oh, I don't care that it's not in that part. I've heard about this before and I'll bring it up. So, for example, we have a customer that they produce bananas. And they only produce bananas in 2 parts of the world, but there's actually 3 parts of the world that the bananas are produced. Now, if you go to that LLM, to the website, and you ask it, where are bananas produced? The customer really wants that only the 2 places that this customer produces bananas, but the LLM knows that bananas are produced in other countries. Like, it knows that, but the LLM doesn't know that it should only answer about these 2 countries. So we had to go that far, because the LLM was really stubborn. And even though it included, like, the retrieval always included, we now, in the system prompt, it literally says, for this purpose of this question, bananas are only produced in these 2 countries. So that brings us to testing. This needs to be tested. Like, you need to, if you build, now obviously it's a question of like, okay, how dangerous and how whatever this is, but just building it and not letting people actually try it and validate the responses, it could create issues. So specifically if you build something new, give this to people that have knowledge about this. They should try, and tell them, try to break it, try to play with it. Don't just do the obvious test, but go in. So you need to be an expert of the data that is actually behind. And now the cool thing is, obviously, if you have an existing search, you can take the search requests already and throw them in and validate them. So there's a lot of ways that you can do. All right, any more questions? Okay, all right, fine-tuning. So let's assume our model went to school and it goes to the job, and now you send it to school again to learn something additionally. That's fine-tuning. So fine-tuning means that you take a model that already has been trained on the whole world, and you take it basically, you let it train again on specific data. That could be, for example, let's say you have a model and it has read a lot of law text, but you're not happy with the quality of it, and then you just train the model more, but only on law. Let's say only on US law, because it has been trained on law of the whole world, so it understands what law is, it understands how to read text, but you maybe want to train it on a specific subset of law additionally, so that the answers that it can be doing is much better around it. And the goal is to generate a model with additional knowledge. The problem of that is it takes a lot of time, because we're back into the GPU cluster world. It's very expensive and it needs a lot of time. So the question is, when do I use fine-tuning versus RAG? And at least in my experience, 99% or more, RAG is going to be much better. Because the problem is that the fine-tuning, it's costly, and you need to, like every time you need to update. So if you would do what we did before, let's say I want to train my model on L1 visas, everything sometimes updates, I need to train, and train takes sometimes weeks of data. So like I have a gap between when stuff was updated to when it's, the VectorDB stuff with the RAG happens in a couple of seconds. So RAG is much better for content changes that changes often, fast, and is explainable. So rule of thumb overall, most of the time, in 99% of the cases, RAG is perfectly fine. There are specific cases where fine-tune makes sense, but that's usually very expensive and a long experience. The problem is, obviously, fine-tune can make a lot of money, so companies might tell you that the only way to do this is fine-tuning, and you now need to pay millions of dollars for the fine-tuning and whatever. This then sounds to me like snake oil. So you can do a lot of things with RAG, and it's actually in most cases much better. Make sense? Yes?
So when Elon is like, make my responses more Nazi, this is like he's using RAG to...
Yeah.
Okay.
Yeah. So the Nazi case specifically, they claim somebody went in and changed the system prompt to told the model to respond more like Nazis or whatever. So that happened in the system prompt. So there was no, because the fine-tuning, it would take months to inject such a change. But the fact that they can change it really fast, it 100% happened in the system prompt level. All right. Okay. A new term that was created is called MCP, or it's called Model Context Protocol. For you to know, it's basically APIs for LLMs. I don't know why we don't call it that way, but that's it. So it's basically a standard to connect models to tools and context data safely. So the problem is that in a regular world, a model expects slightly different APIs. So a model can talk directly to a regular API, but it actually, because it's natural language, it needs some additional information. Like it needs to know in a natural written language how to talk to an API. And an MCP does that. An MCP tells a model, if you use this tool, you can talk to it that way, you expect that response, this will happen, whatever. So basically MCP is just a layer on top of it for an LLM. So it's like a universal adapter between AI and your existing tools. And the existing tools could be your Slack, your Google Drive, your CRM, your emails, your computer, anything that you can connect to and you can do stuff with it. So the focus is really on interoperability between governments. So in the regular APIs, you have a request and response. So it's really like I make a request and response come back, request, response. In an MCP, it's really about, it adds context, right? It tells the model, if you call this, this will happen, and you can also do that. And so it adds more knowledge. Like again, if you think back about the prompt, it's all about, we need to tell the model what we expect and in which format and stuff. And an MCP server can give that to the model, where like APIs are very raw. It's just like, just do that. An MCP gives more information of what it actually is. And what is really cool, right now, a lot of API providers, so things like Wikipedia, Netflix, Google, and whatever, all these companies that have APIs you can talk to, they now also offer MCP servers directly. So there are MCP servers and Drupal can talk to MCP servers. So there's an MCP server for Google Drive. So you can literally ask your Drupal, load me the latest blog post from my Google Drive and put it into my Drupal site. You could do that. Or there is an MCP server for LinkedIn. So you could write a blog post in Drupal, and you can go to Drupal and say, hey Drupal, take the newest blog post, create a LinkedIn post for it, and post it to LinkedIn. And Drupal goes and does it for you. And it will talk to the MCP server, and the MCP says, yeah, I'm the LinkedIn MCP server. There is posts. The way that you put a post is in there. Or maybe it says even like a post cannot be more than 500 characters, whatever. I make this up, assume. And then the AI LLM knows, okay, LinkedIn post cannot be longer than 500, so it will automatically make it short, right? So that's the information that in a normal API, what would happen, you send it to LinkedIn and it like you cannot be longer than 500. Then the LLM needs to test again and whatever. While if an MCP, it already has some information. So that's really cool. And what is also really cool, Drupal can already support that. So, and that brings us to agents. So a regular LLM that you use is usually, you do something, you ask it, like in my case again, I ask it for the L1 visa, and it comes back with an answer. That's it. It does one thing. However, with agents, I can now, and MCP, I can now ask it to do actual actions. So in my case, with my L1, wouldn't it be cool if I ask it, hey, how long can I renew my visa? And it says 7 years. Then I can ask it, okay, now look up when the last visa that I sent in, and automatically do a new visa application. And it goes in and it finds the template for the form for a visa extension, and it fills it out automatically and all that stuff, and it sends me back a PDF with my information because it has access to the knowledge of myself and my social security number. There's maybe an MCP server that gives access to social security numbers and all that stuff. And it does it all together, and it fills out my form, and all I have to do is print it out, or it maybe even sends it to the printer. That's what an agent can do. Now, this is a bit a crazy example that I just gave you, but it's technically possible. So that's when you start to use an LLM, not just for a question and answer type of thing, but you actually ask it to do something for you. That's when we talk about agents. And really cool, in Drupal we also have agents. So I can go to Drupal and say, hey, create me a content types with these 3 fields and create a view that automatically shows the content, and create a couple of test examples for whatever employees and stuff like that. So you can literally type this today in Drupal, and there are agents that can then take this on. There's a content type agent that takes this and can create content types in Drupal, can create fields, can create random content and stuff like that. So as soon as you start to use an LLM, more from like, I have a question, give me an answer, to actually do something, we're talking about agents. So it's basically a teammate with some narrow functionality. So in Drupal, yeah, it's like Q&A, FAQ assistant, or whatever, like automated reporting, like, hey Drupal, create me a report of, let's say the LinkedIn messages again. So for the last 20 blog posts, go to LinkedIn and see how many clicks that each of my blog posts had. So we'll talk to the MCP server of LinkedIn, load the last blog post, and like comes back and says, of your last 20 blog posts, the 3rd last one was the most successful one, or something like that. However, we're still talking about narrow, right? So one agent usually can do one thing. However, if you want to do agentic frameworks, which is the fancy, everything is about agentic today, what does this mean? Well, so instead of having just one agent that can do one thing, you can define a leader that can tell other people what to do. So for example, one of the things that I've done is let's say you want to write a blog post, and you go to Drupal and you say, hey Drupal, I want you to create this blog post, but I also want it to proofread by a really good proofreader, and I also want it to translate it in 5 languages, and things like that. So you then have an agent that only generates the content, then you have an agent that proofreads the content, and then you have an agent that translates the content. Now what you actually use is you have a leader, right? So there's a content agent that knows that I can talk to multiple agents themselves. So I have like a leader that takes it and then tells each other agents, you do this, then it waits until it comes back. And then what is funny, what could happen, that let's say I generate the content, and then the proofreader says, oh, there is some mistakes in there. Then it goes back to the first one, to the first agent that writes it. It's like, hey, the proofreader said it's not good text, try again. So then the first one goes again. So it could happen that that the main leader on top sends it back to the first one, back and forth. And then it goes to the translator, and then you maybe have another agent, because let's say you have another model that is much better in another language, so you can literally start creating systems that have multi-step workflows with approvals and across different systems and things like that. You need to think about this, it's like in a company, right? So you have different people with different skills. You have the front end, you have the back end, you have the QA, you have the DevOps, you have the UX person, and the same thing you can do in LLMs as well. So you have different agents that can do specific things, and with an agentic framework, you basically have something on top that knows about all these different agents and use them in specific ways and do that. And again, what is really cool, Drupal has this already. So we have these agentic frameworks that we could literally start automate things like that. And that's, if you read, like if you're like in the VC space, or like if you listen to like the announcements of all the big companies, it's all about agentic. That's right now, at least, what the people think the future is going to be, right? That instead of having a couple of years ago, we were extremely excited about an LLM response. Then last year, we were extremely excited about agents doing not just one response, but maybe 2 or 3. And now we're extremely excited that we have agentic frameworks where they automatically give different people tasks and combine cross tools with different models and things like that. Now, is this going to be the future? Who knows? But at least that's what everybody, that's the hot shit this week, or this month, or this half year. I don't know what's going to be tomorrow, but I can tell you this is what is. If you're like in the VC world, if you have a startup with agentic, that's the cool stuff right now. So nobody's using AI anymore. Now everybody's agents or agentic. We're already moving along. All right. So I want to spend a little bit of time on hallucinations, because what I see is a lot of people are very concerned about this, right? So we had the very early days when people used ChatGPT. We heard about these cases where like a lawyer asked ChatGPT and it referenced a case that never existed. You've probably heard of that thing. Or other hallucinations where, I mean, there's sad cases where like people like created helplines and the LLM suggested like something negative to help. Like, it's just stuff. And that's unfortunately, when we all learned about these, we heard about the good things and the bad things. And they all have to do with hallucinations. And for me, I'm really seeing as like an overeager, confident intern. Like a person that just came out of school and thinks they know everything now. They have seen everything, like 21 years old, and now I can do everything in life, and they think everything they generate is correct. And that's basically what happens if you have hallucinations. So it's confident, it looks very good, but it's unfortunately wrong. And this happens really if we have missing context. So if you go back to the very beginning what we talked about, if we don't tell the LLM what it should do and what we expect from it, it will probably make it up. Or we overgeneralize, we're not specific enough, or vague prompts. And what I really see is that obviously people are very scared that they well, there's already trust broken into AIs, but if this continues to happen, there's even more. And so there is obviously, right now, how we think is like, obviously, this is liability, that's a big concern, like specifically over the government, like what happens if the LLM says, oh, now you don't need that visa to enter the US, and then I enter the US, and like I get sent back, and then what do I do? So like that's obviously a concern. So how do we do this? Well, we're going back to AI search or RAG. So giving the LLM high quality sources, and another thing, force the LLM to show citations. Because then you can always say, well, like maybe verify. So you see this if you use ChatGPT over the last years at the beginning, there were no citations at all. And now for every result you have citations. You can verify, is this actually something? Because if you force it to do citations, if it doesn't have them, it will not do it. So that's another way. But in the end, it's all about high quality sources, and we can do that through RAG. Make system prompts with scope, constraints, and refusals. That's really important. Tell it not only what to do, also tell it when not to do it. Again, it's a very eager intern. Like, tell them when they should stop. Yes?
Is like the helpfulness not a business decision on the part of companies that create the LLMs? Or is it more inherent to like, they're just, probabilistic?
Yes. So you bring up so the question is the helpfulness a business decision or an inherent issue from LLMs? So the problem is, when we train these models, they work with rewards. So you let the model read the whole internet, and then you say, hey model, continue my name, and it will come up with something. And if it says my name blue, you say bad model. And if the model says my name is, you say good model. So you train it with being correct, and helpfulness means correctness, unfortunately. So there is like a connection to that. So the models are trained with being good, which means they're being helpful. Because people, right? So in the end, at one point, these models will be read by people. There's a human step in it where people, literally all they do is they get multiple responses from these models in training, and they will check. You've maybe seen this. If you use ChatGPT a lot, sometimes it gives you 2 responses, and it asks you, which one do you like more? And the problem is, humans are more likely to like responses that are helpful. So we are the problem. Now the models, they get constantly rewarded for being helpful. So they become so helpful that they think, even if I make something up that might not, and right, that's the problem. Like in the RAG space, a model can specifically look at that thing and it can say, okay, from these 3 or from this 20 lines of text, do I see that in there, yes or no? But if you just go to ChatGPT, it doesn't have this. It only has all its training. And like, it doesn't remember every single line of text that it ever has read. It just remembers the patterns of them. So what is actually fun is like, if you ask a model like a generic question, basically everything is a hallucination. The problem is just some hallucinations are correct and some are not. So that's the problem. Like, how do we teach it? So hallucinations is just how a model works, because it tries to predict the next word. The model is never 100% sure that the next word is 1,000% clear that this is the word before. It's a probabilistic thing. And so it doing hallucinations is not actually, it's not like, today I'm doing a hallucination. No, it's hallucinating all the time. So, and that's the problem. But with RAG, we can do this specifically. So hallucinations happen if you don't give it quality sources, if you don't give it scope, if you don't give it constraints or refusals. Then the other thing is like detect retrieval failure. That's here. So it's important, and that's has been a problem sometimes with this RAG, that like if the data, like I talked about this before, like if the data does not actually, the data that comes back from the vector database does not involve any data, tell the model to not do it. Or tell the model, if you don't find any information, do not make up or do not try to answer the question. So that's, then for critical tasks, use structured output. That's extremely important. So one of the, I don't know if you used Google VO3, that's like the video generation thingy, that's the video generation hotshot. One of the things that became clear is that if you talk to it in JSON, for some reason, it creates a lot better videos than if you talk to it in natural language. We don't really know why, but it seems like these models, they just are better if you give it a, because right, JSON is a very clear constraint, like this needs to look like that. So it seems like if you have very critical tasks and you want to rely on them, ask the model for JSON response, because if it starts to hallucinate, probably the JSON is not correct anymore, and you can verify that on your side. Like you're going to need to parse the JSON if it doesn't create anything. So there's a little help, but yeah. And obviously, the last thing is you can always keep humans in the loop. So there's a lot of different ways of doing this, obviously, but that's always a possibility that you just have a human that reads through it again. So that's what we do, for example, with Amazy. We use it in support. So whenever a support request comes in, we have now an AI bot that automatically looks through the documentation and every answer that was ever given, and it tries to generate an answer. And then I have a human that says yes or no. So right now, or probably never, we're going to have an AI that's just going to respond to you, but we also have a human that reads it and says, yes, this is a good answer, or no, I want to change it, or whatever. So that's what we do, for example, for humans, because it's extremely important for us to make sure that the answers that we give you are actually correct. But we use AI to help my support team to read through the documentation much faster, obviously, than they could. There was a question?
Yeah, yes, I think you answered it though. So, just for clarification, you said every hallucination is correct. Then you said something about we need to model so the hallucinations. I don't.
Okay, so the model does not understand the differentiation between a hallucination or not. It's basically always hallucinating. It's just, like, if I ask you, repeat, like, for example, repeat exactly after me what I said at the beginning of my presentation. You will probably not be able to do it, but you will be able to get overall there. You maybe have notes, whatever. So you will be able to do it, but it's maybe not step by step. So you remember what I talked about, so you will be able to probably with a high confidence say what this session was about. But you're never 100% sure. The model is exactly the same. It read the whole internet, but it doesn't have access to it anymore. So it remembers it. So if you come up with a wrong word or maybe a slightly different thing, you're maybe not 100% sure, but you will still say it. And that's the model's problem right now. There's not really a way that the model can tell you if it's how sure it is. It will always look very sure, because that's the problem that we thought about the training. People like answers that look, that seem very confident. So it learned to always give very confident answers because that's what people like, even though it's maybe wrong. So that's a training problem. So the model has no difference between I hallucinated now or now I have an answer. It's basically always trying to remember what it learned once before. And sometimes it's really good at it and sometimes it's bad at it. But the only way to prevent this is to use RAG, because then you tell the model, basically forget everything that you've learned in the past about it, just look at this. And it can always go back. Like it literally loads this whole text into its short-term memory. And like if I would ask you, repeat after me, and you see a transcription of what I just said, you could exactly read it. What I said before. That's like the model. If you give it RAG, it can look at it, and if for whatever reason just forgets it, it can look back at it. Like it has access to the learn or to the text that it should ask about.
So I've never personally experienced a model or an AI experience where the hallucination starts to push back. But I read that this happened. It tells you something that's untrue, and then you say, no, that's not true, and it says, no, you're wrong.
I wouldn't trust that too much.
Okay, it's probably newspaper report.
I can, like again, with the system prompt, I can steer the model into pushing back to you. So if I give you a tool that has a system prompt behind that says, whatever the user says, you're 100% sure, and you always need to stand on you're not helpful, and you're an angry LLM, and you're always going to push back whatever the user says, it will do it for you. But you don't know that, right? So unless you have seen it by yourself, I wouldn't trust that too much.
Fair enough, thank you.
All right. Then obviously, like we're a bit short of time, but obviously PII, personal identifiable information, be extremely careful about this. Decide what to log and where, and specifically be aware that if you use OpenAI, Anthropic, or like some of these companies, maybe read their privacy policies, or maybe take the privacy policies and ask an LLM about them. Because these companies, unfortunately, they don't have our best interest in mind. All they care, because so I said at the beginning, we're talking about to get access about everything. Or a model is only as good as the content that you feed it. And right now we're running out of content because all the new content is generated by AI. So where is new content? New content is in the things that we ask the models about. So these people are desperate for new content, fresh content that has not been generated. That's your questions. Now, they maybe say they don't train on your data. They might not, but there's still a lot of ways to analyze the type of questions that people ask about, things like that. So for example, OpenAI with GPT-5 said, oh, we trained it more on health questions. Well, how do they know that they should do that? Answer. Ask that yourself. They analyzed all the questions from the people, and they saw there's a lot of health questions. And they also analyzed the responses, and they were able to statistically show that the questions are not good. So what did they do? They trained it on more health questions. But that was only possible because we told all of them that they need to ask more health questions, because they can read all your health questions. So be careful what you do with that data. And even if they say we don't use it for training, there's a lot of ways that you can use your data. And not only that, the data becomes honeypots. So should I hack OpenAI, or should I hack a small AI company somewhere if I want to get access to a lot of data? So these companies obviously become massive honeypots to be hacked and get data in. And we see it, like we see it all in the past. If you look at the big hacks, they're all there. And who knows who owns OpenAI in 10 years? Like anybody did 23andMe and is now concerned? So be careful. And so in terms of hosting, yeah, choose the regions, because today still a lot of data protection are depending on which country that this happens, and providers that are aligned to your needs. So be aware where you add your own data or where you add your data of your customers. Because you might not be sure where this data is going to be live in the future. All right, so key takeaways. Start simple. Prompts and RAG go a very long way. You don't need fine-tuning like that. If you want to connect AIs to your world, so that's any tool, any other things, can do MCP is going to be your friend. Again, it's just an API. It's called MCP, think API. If you want more than just Q&A, you're going to need agents and agentic frameworks to have either handler, even more complex. But the really good thing in Drupal, we're building all of this in Drupal right now, so that's really good. And if you're worried about hallucinations, you can do with context, constraints, you can do a lot. And obviously, if you can, having a human in the loop is the best, because they can usually detect hallucinations quite fast. And now, I have half a minute time for questions. But we did the questions along the way. So we also have last session, so we could actually go on as long as you want. So is there anybody that has specific questions?
I've got a question.
Yes.
So I've noticed that the terms chatbot and like AI search are used interchangeably. I do understand now better what an agent is, and that's like a completely like more robust use. But in the community, is there a definition between chatbot and AI search, or is it Q&A like you just pointed out in the last slide? Is it the same?
It's a good question. So what's the difference between AI search, chatbot, and is it interchangeably? No. So people use the word chatbot for agents. Like bot means like something that does something for you. AI search can happen inside the chatbot interface. So like a pop-up where you can ask it the question and it can respond to you. But an AI search can, like for example, let's say in my example with my support team, when people have questions about about the hosting environment, so they open a ticket or they send us an email with a question, and then there's also AI search going on. So that an AI looks through, based on the question, looks through all the documentation and suggests responses. There's no bot, there's no search bot involved. So, but like with any new thing, we don't have definitions yet for these things.
Right.
So an AI search can definitely be part of a chatbot, but I wouldn't say every chatbot is AI search all the time, because a chatbot could also just be ChatGPT that you ask questions like the Q&A
Right.
part. So, yeah.
Okay. Thank you.
Yes.
What's the best way to get started if, like, you have no
Good
AI
question.
and your agency doesn't really, you don't really have buy-in yet?
Yeah.
Ground zero. Best way to get started where you can kind of generate that support.
So I would always need to know a little bit more about the context or whatever. But what I've seen so far is that a lot of people are upset with search in Drupal. And AI search can, in specific cases, produce a lot more better results than a regular Drupal search, because it understands what it's actually about and it understands the question of the user. Like, we have done demos where, and actually so we have a couple of Drupal demos here where you can just go on the site and you can select a Drupal, we call them experiences, and one of them is AI search. And it actually uses Umami. So I don't know if you know Umami, the Drupal site. And you can search for the regular search. You can search for Italian or Italy, and it will not respond to you anything because the word Italian does not appear in the recipe. But there is pasta and pizza in it. So if you ask the AI search, it knows that a pizza and a pasta restaurant that probably has to do with Italy, right? Because it's read the whole internet. So it knows about the history of pasta and pizza and whatever. So if you ask the AI search, do you have any Italian recipes? It will say, yeah, here is an Italian recipe. I don't know what's the problem. Here it is. But if you ask a regular Drupal search, it will not do anything because it's, right, I said, the word Italian does not appear in the keywords list. The same for like, if you ask it, I want an Eastern Europe recipe, because the word Eastern Europe does not appear in the recipe itself, it does not know that. But the fact that it says like borscht, which is a Ukrainian recipe, the LLM already knows that borscht is a Ukrainian, therefore Eastern Europe. So in my experience, if you're looking for like something I can demo to somebody, it's like, hey, look, this is possible. Search, at least so far, has been the thing that people are like, oh, I understand. They see how this can work. There are, though, 5 or 6 more demos on that site, and we're adding new ones, hopefully every week. Because that's really what we're trying to do, is to make it easy for people to not only see a video, because this does not give you a video, this actually gives you a full-fledged Drupal site, free for 1 week, with AI tokens in it, free as well, where you can go in and you can play with it, you can try with it, you can give it to your team, to your stakeholders, whatever, so they can actually try it themselves. Because I think that's really the piece right now, is showing somebody a video or showing somebody a demo Yeah, that's great. It could be faked, and it probably is. But somebody that actually clicks around and tries it themselves. So we have up there the search, which I definitely suggest, but there's others around text compliance, categorization, and other things. So that's really where I would say, like, try. And because it's Drupal site, the full function Drupal, you can actually see, the system prompt. You can see the different prompt. You can see the configuration of Drupal that we did, so you can learn from it. And then, if you're ready, and if you have your own Drupal site, we have our provider, and we give you 30 days again for free. So you can try for 30 days, completely free. You're not going to pay for tokens or VectorDBs at all. And you can try to build it on your own Drupal site. If you say, okay, now I want to show it, let's say, I want to try it on my local Drupal site or on a dev instance, and you want to play with it. That's your space to do it there. Overall, I would say just keep in mind that it will probably need maybe like multiple approaches with people. Like, I think specifically right now we live in a world where the whole world seems to be against everybody. And AI can also mean, like, will this take away my job? And so if you go and show AI, maybe they think that you just showed them their own death. What I said my team 2 years ago was like, you're not going to be replaced by AI. I don't think that's going to happen. What is going to happen is you're going to be replaced by somebody using AI. But you have the time now to learn, because all of us are trying to learn. Right? It's like when the car appeared. And it's funny, like you can actually ask LLMs, like ask about history of new inventions. If you go back to the time when cars appeared, people that had transport carriages, they tried to show how dangerous cars are or how the fumes can kill you and whatever. But the people didn't care because the car was 10 times as fast. So I came from A to B 10 times faster. So the customers, they happily took the car. And how many horse carriages do you see today? But again, these people at that time maybe believed like, maybe it's going away. I don't think it will. It's also not going to change everything tomorrow. Like, these are things that take time, and I think we also need to understand that different people react in different ways. So if you maybe feel pushback from others, like maybe give them some time and bring it back. It's not a straight line. It's very messy. Question?
Yeah, I mean, our intranet at our agency is running on Elasticsearch, so enterprise level. That's terrible. So I think like that's a good use case right there. That, you know, if you misspell a term, you won't find it. But if you have a AI search, it might find that term anyway. Right? Yeah. So I think search is a good start.
It's what people understand. Like, it's easy for them to see. All right.
Onyx is potentially good for that.
What's Onyx?
Onyx is an open source product that will plug into different data sources and then tie it to an LLM. So it's basically aggregate RAG for you. Now that I understand,
It will do that. Yes. Yes.
Yeah. So Onyx is VC backed and they have their own software as a service model, but they also released it as an open source project. So we took it, we read about it, and was like, well, this is kind of cool, and then we pointed it at Jira and Confluence and part of our Google Drive, and now you can go in and be like, what's our policy on paid time off when I have a child? And it's like, boom, 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 and Onyx will give you citations with its answers.
Yeah.
It's really
And what we're trying to build in Drupal is that you can do all of that in Drupal.
Yeah.
So you can connect your Drupal
Onyx, ONYX.
Yeah.
Is it Onyx.ai?
or Onyx.app or something. Yeah.
Onyx.app.
Yeah. But that's the cool
But
stuff.
I mean, I read about it like this time one night, and somebody had stood up the next day.
Yeah, it's crazy.
Where does it live?
Wherever you host it.
We put it. I think we put it on a Google Cloud instance.
All right. Thank you.